right, so this is project three, the Nanjing Navigator 3000. It's me, David, Jay, and Benjamin. For this project, basically what we're doing is we're comparing two different algorithms, A star and Dijkstra's, and we're getting a source node and a destination node, and the whole motivation would be to find the most efficient and quick route as possible. An example of a problem is based in Nanjing, China, where an AI-powered robotics company created an autonomous car for a locksmith service. So what we would do is basically be able to give the routes to these robots for them to get there and help their customers as fast as possible.
Okay, and this is our entire code right here. It's all in a notebook style Python file. So I'm just click
Mhm.
restart and run all. And then Ben could talk a little bit about what packages we imported and a little bit about like the data cleaning process.
Yeah. So at the top of the file, those are the packages that we required in order to do our data manipulation, visualization, and just data storage. The installs are just stuff for visualization as well. The data came in an unfamiliar file type, so we wrote a couple functions that we later commented out but kept in for your sake, just to turn them into CSV files, which are much easier to use. And we did that for both a coordinate file and a node-to-node distance file.
Yep, and these are also functions that help convert the CSV into a readable, or I guess into a data structure. The read underscore graph function converts the CS like the actual map, the graph like CSV into an adjacency list, and read underscore chords converts the coordinates into just like a dictionary map with source and latitude longitude
Yeah,
coordinates.
yeah.
And then right here, this is just we uploaded the CSVs to GitHub, and this just allows for anyone who could run this repeatability, things like that.
Yes. So these are all helper functions that we use to calculate distances after we got the paths from our various algorithms. All they do is one returns total distance while reconstruct path takes a Dijkstra output and then returns a path including the distance as well.
And we only use this one in the Dijkstra
And then Euclidean distance, that's
function.
just, yeah,
Yeah, Euclidean distance is just for A star,
yeah,
and then visualize underscore that's just to that's just for visualization that we use later at the very end. Okay, so
yeah.
this is our Dijkstra
So
algorithm
this
implementation.
is the Dijkstra. Oh yeah. So the Yeah, it's the same thing as we've learned in class. It's just I used a heap and just went from our source node and just visited every node, finding the shortest distance to each node, and then so on, going through the neighbors, then returning two dictionaries, one with the previous like the previous nodes, then one the distances to it, and then from there you're able to then find the shortest path between any node and then a resultant destination node.
Yep, and then this is our A star implementation, which uses the heuristic, which in our case is Euclidean distance. It also uses a min heap. What does it use for reconstruct path? I just coded it within here from like the previous, I guess, map or dictionary we have. It's pretty similar. It just has like a cost or like a score that uses like how far, like where they are, then plus like the raw distance between where they are then in the destination. Um, and so, just for sake of time, this is the visualization component, which we are using Folium to display two maps. So if you click compare algos right here, you're able to run as many queries as you want. So this is Dijkstra on the left and A star on the right. And if you click this as many times, it shows the statistics to randomly generated destination and end nodes. Just for like this is just for like the company to practice, the self-driving robots, and the path will be the same basically every time. I've never seen it not be the same. And you can see sometimes A star's quicker, sometimes it's not. It's interesting how it varies. Um, but yeah, we color coded the two different paths, and it honestly could just be one map, but I thought this would be a little bit clear.
Yeah.
And yeah, that's about it. You can do this as many times as you want. I think it's pretty interesting, and yeah, that is our project.